All right, Katie. I think we are on our last problem, which you're probably happy about if you're even watching these things, and I'm probably happy about. So now we have this problem. Whatever's going on, the guy is throwing the ball 4 meters above the ground. We could say this: h sub 0 equals 4. And we know that by the time the ball hits the ground, this distance here is 25 meters. We have our basic equation that I think is going to apply here, which is that the height of the ball equals h sub o plus, we're really interested, well, I say this, we're mostly interested right now, if we're talking height, we're in the y direction. So this first equation we're going to draw is just y stuff. Equals v sub y o, the initial y velocity, times t, minus 1/2, 9.8, that's acceleration due to gravity, times t squared. We're using this equation a lot, so it's obviously something you need to integrate. Why do we care about all this? Because we know that the height has to equal 0 when it hits the ground, and that's part of I didn't want to erase everything. That's part of what we're dealing with here. And we know that h sub o equals 0. We don't know, in fact, it's what we're really interested in, is v sub yo equals what? That's our question. And so we need to find out what's going on here. We know h equals 0 because we want to find out when it hits the ground. H sub 0 equals 0. We know, so actually the way I'm writing this right now, I'm confused because there are two things we don't know. What I'm writing down right now is that Vy sub o, the speed that he's throwing it at, times t minus 1/2 times 9.8 t squared equals 0. The problem with that is there are two unknowns in there. So there are two unknowns and we only have one equation. So that's not really the right way to think about it. So let's think about what the right way to think about it is. Well, what are we not using? We're not using the fact that we know that it went 25 meters. And in the x direction. And the distance in the x direction is going to be equal to the velocity in the x direction times time. And that is this velocity in the x direction is a constant. So, and we know d sub x is 25. So that's equal to some constant. V sub x is a constant times t. I guess because I did this earlier and I didn't hesitate on it. I mean, I could say, so I'm contemplating what I did before versus what I did now. Well, this was wrong with what I said before. That should have been a 4. My initial height, because that was the initial height originally. And so even this equation here is wrong. All right, I'm doing this over. All right, Katie, I think I'm ready to run through this one. This is the last one. This is problem 47. Your velocity in the y direction is, and this has to do with this little triangle. That's your velocity. That's your velocity in the y direction. That's your velocity in the x direction. On this problem, well, it's dumb because the velocity in the y direction initially is 0 because the guy's throwing the ball horizontally. And the velocity in the x direction initially is v because all of its velocity is in the x direction. So writing these things down was kind of stupid. They don't matter. We have the initial velocity in the y direction is 0. That's this guy. And the initial velocity in the x direction is the entire velocity. Then we have the equations that say the velocity in the y direction is equal to the initial velocity times time plus the acceleration times t. Well, this part goes away because it had no initial velocity in the y direction. And for this guy, the acceleration in the x direction goes away because there is no acceleration in the x direction. And well, that part of it's wrong. It's just the initial velocity in the x direction that is constant. Now we have the height of the ball. The initial height here is 4. The initial velocity in the y direction is 0. And the acceleration in the y direction is g, which is negative 9.8. So I can rewrite this equation and say that it is h equals 4 plus, this goes to 0. This is negative 9.8. negative 9.8 t squared. We really, for this problem, what we're really interested in is stuff about when it hits the ground. And that says that we want to know when the height equals 0. And that's going to give us this equation. So we'd have 9.8 t squared equals, well, that's not the way I want to do that. Let me erase all of that. I like it the way it is. I like that. And I'm going to rewrite it. I'm going to take the right side, move it to the left side, and I'm going to say that that's equal to t times 9.8t minus 4 equals 0. Make sure you can follow how I got to that from this equation. But they're equivalent. Then that tells me that my zeros for this function are either t equals 0, which is kind of irrelevant because what's going on here is, well, let me skip that part of the concept. I either have t equals 0 or t equals 9.8 over 4. No. 4 over 9.8. And so that's really the time I'm interested in. And if that's the time when the height equals 0, then I can plug that into this equation to find the distance that is traveled at that point. And that is going to be d sub x equals 0, because my initial distance was 0, time plus my initial velocity, that's really what we're interested in this problem, times t, which we now have a value for, plus, well, this 1/2 acceleration in the x direction, that's equal to 0, so this whole term goes to 0. So it's really just my d sub x, which is 25, that's how far it took to hit the ground, equals v sub x 0 times 4 over 9.8. I hope that helps you, Katie. You can call me. I'm going to send you an email asking you if any of this stuff helped. And let me know if it helped, and I'll talk to you later. Bye.